This is going to be a video about the history of battery management systems. And I'm doing this with all the old battery management systems that I've had in the past for different projects while I'm cleaning up and throwing stuff out. This one right here was popular when the first prismatic lithium batteries came out. That attached to the positive, this attached to the negative. It sat right on top of the battery, and these two spade terminals would daisy chain like Christmas tree lights from one to the next to have a huge loop. And at the end of the loop was a little control board, and as long as every one of these modules was happy, it would keep the relay on. And if you were driving it or if you were charging, and that in turn would then turn the charger off or sound an alarm on the low voltage. It also had a little flashing LED light, and if the voltage ever got too high or too low, the light would start flashing, and it would keep flashing for the next half hour. So you could look back over your batteries and see which battery it was that was not performing correctly. It was not settable. You couldn't set this for anything. These were for the iron phosphate. So they were basically 3.65 would be where the balancer would come on. And I think and then I think at 3.7 it would open up the circuit between these two spade terminals to send off the alarm. And I believe on the low voltage it was 2.5. So if it got down to 2.5, and these were pretty good. They were about $15 a piece. And of course that was back when gas was $1 a gallon. This was one system. Here was another system that actually was around that time. And what this did is you hooked it to one battery in front of the other in the string. And this, when the voltage got up to a certain voltage, I guess, probably 3.65, it would start pumping the electricity into the battery next to it. And you'd have a whole string of these all the way around your battery pack, so you could actually pump the electricity all the way around. Now, there wasn't any way for this to send back a signal to tell the charger to turn off. There wasn't any low voltage either. You just set your battery voltage from the whole pack, whatever it was. If your whole pack was 150 volts, you'd set your charger to turn off at whatever that would have been charged voltage, and your low voltage alarm would have been. So it wasn't real good. Here's another one that was like our first one. Again, just a balancer though. It had no way of sending back or talking to the charger, but it did do a much better job of balancing. This guy here would balance at about a half an amp, and this guy I think was an amp and a half. That's what all those little resistors were. Here was a charger combined with the BMS, and this was on the board. And you see he's got all these little adjustment pots, so you could adjust him. He's also got one transistor or MOSFET for each cell. So when the cell got up to a certain voltage, it would turn that charger off or on. But still, again, no way to see. We've come so far with the management systems. It's really amazing. Much further than I have come at cleaning up my workshop here. This is my little electronic workshop that I had at the other house. We moved it, and I have yet to get it organized yet, but I'm working on that. So moving into the future, we have, this is the Orion. Now, he's been around for a while. Very good system. You still have to run wires to each battery, so it takes a lot of wiring. A new system that I'm working on with a friend of mine is this one right here that he's doing. And this one uses the old Tesla boards that are on the Tesla batteries to begin with. So we don't have to individually wire all the cells together to the sensor. The board itself does the balancing, and here's what these boards look like off of the battery. They bolt right onto the battery. That's where they clip on there and there to get the voltages, and what it sends out is CAN messages. Pretty neat. So that the good thing with that is you don't have high voltage wires all over the place. You just have 4 of these CAN wires that end up back in here, which sends the information, and we can see all our battery voltages on here. Now, I'm draining these down right at the moment. Now, this is a whole pack of 16 cells, which we're getting ready to put in some car. And we've charged them up. I individually balanced them to get them pretty close by putting a 24-volt power supply across here. I haven't individually charged or balanced each cell, but their balancer does that. And you see this, what you see here is the red and the light-colored screen. Those are the ones that are being balanced at the moment. No, I think the light-colored screen is the highest and the lowest, and the red is the one being balanced. So you see, if you look at this, they all are very close to being balanced. Now, I've run into a bunch of little problems in getting these things here, and you'll see where these have these ribbons, which in handling or whatnot have gotten torn, and I've had to attach wires to bypass the ribbon. So what I got down here is my gauge that's showing how much I'm drawing, and I've pulled 168 amp hours out of these batteries, and now we're only pulling we're actually charging 1 amp because I have these also hooked to the solar panels. So yeah, this is the problem, is what to do with all that electricity once you pump it in there. I got this right here that I can switch the shop here onto that inverter over there. And now we see we're pulling out 4 amps, which is what's running all the shop and all that. I have, this is one of those solar inverters, and there's our battery voltage from this big pack, and I'm pumping that into this as if it was solar electricity. So it's taking all this 300 and whatever volts it was and making it into AC to run stuff. And that's how we drain it down. Draining this down is part of our challenge. I have this heating element that came out of an air conditioner, and this works very well for draining down batteries. I've got them all those tied together, and the alligator clips, and I can put this on an individual battery to get him a little lower if I need to. That's my input. And I also charged my car last night with it, which it stopped charging for some reason. Maybe it's full. I don't know. It says it's charging right there. Here's I just, this is a new array I just put up there of solar panels. So I got lots of energy when the sun is coming out. But when I'm testing batteries, that's where I use these Andersons. So I just have this plugged into the same thing as the solar. And that way I could discharge these batteries and charge my car last night. Which we see we're drawing 4 amps from that. So, yeah, that's our setup for more on this guy later. I guess that's long enough video.